This video will review an alternative formulation of the constraints for the sales and operations planning model that will work with the solver on Mac computers. This material is also in section 2.6 of the SOP tutorial. In Excel, I have opened the model that was developed in the SOP tutorial and the other two videos on sales and operations planning. All of the formulas are in the model. The decision variables simply contain starting values, and the solver setup is incomplete. At the bottom of this worksheet, I've created a new section that lists the 7 different constraints that are considered in this model. The first 2 constraints are really implicit in any of these models, and that is that we'll have some constraint on customer demand and some constraint on production capacity. Initially, we assume that we will meet all customer demand on time, which means that the units available to meet demand is greater than or equal to demand. To modify this constraint, what we'll do is just move demand to the left side and write the constraint as available to meet demand minus demand is greater than or equal to 0. So we'll enter this formula for constraint 1. In the section at the bottom of the page. I'm going to enter all of these constraints for month 1 and then copy them over. The second constraint is that production cannot exceed capacity. In other words, production capacity is greater than or equal to units produced. We rewrite this as production capacity minus units produced is greater than or equal to 0. So we enter this formula for the second constraint, production capacity minus units produced. Units produced is a decision variable. Clearly, the negative sign means that right now the starting values in the model do not meet the constraints. But that will solve itself when we use solver. The third constraint in this model is a maximum hiring per month constraint. The workers hired in a month are less than or equal to the maximum hires for the month. On the second line, I've simply switched the inequality around to be a greater than or equal to inequality. And then on the third line, we algebraically change this so that 0 is on the right-hand side of the constraint. Maximum hires per month minus workers hired is greater than or equal to 0. And so we enter that in the constraints section below. The next constraint is the maximum overtime constraint. Overtime hours assigned in a month must be less than or equal to the maximum overtime hours per month. On the second line, I've simply reversed this inequality and said that maximum overtime hours per month is greater than overtime hours assigned. And then on the third line, I've simply subtracted overtime hours assigned from both sides to write this constraint as maximum overtime hours per month minus overtime hours assigned is greater than or equal to 0. maximum overtime hours minus overtime hours assigned. The storage capacity constraint dictates that ending inventory is less than or equal to storage capacity. We could also write that as storage capacity is greater than or equal to ending inventory. But to put this as make the statement that is greater than or equal to 0, we take storage capacity, subtract ending inventory, and enter a constraint that that's greater than or equal to 0. Storage capacity minus ending inventory. Again, the negative sign means that with the starting values, the constraint is not currently met, but this will change when we use Solver. The last two constraints are related to supply chain agility. A company may want to have a capacity buffer to meet unexpected demand. This means that the excess capacity is greater than or equal to its minimum capacity buffer, or excess capacity minus the minimum capacity buffer is greater than or equal to 0. The excess capacity was calculated already as the production capacity minus units produced. So for this constraint, we'll take excess capacity minus the minimum capacity buffer. Right now this is set to 0, but in future assignments we'll experiment with changing this capacity buffer. The last constraint is a potential inventory buffer. If an inventory buffer is selected, the ending inventory must be greater than or equal to this minimum inventory buffer, or ending inventory subtract the minimum inventory buffer is greater than or equal to 0. This is a reformulation of the constraints where all of the values highlighted are greater than or equal to 0. And with the constraints set up this way, any of the solvers, including the Mac solver, can handle this easily. You may prefer this even on a Windows PC because it's very compact in terms of the way you would enter this into Solver. Opening Solver. I'm going to reset the solver just to start over. The objective in the solver is the total cost over the 6-month period, which is minimized. The changing variable cells are the decision variables. In this case, they're starting values in the decision variables. Let me highlight all these cells. And then we've already gone through in a lot of detail the constraints and calculated the cells at the bottom that handle the constraints. So all we need to do to enter these into Solver is highlight all of these cells on the left and make those greater than or equal to 0. It seems to be this right-hand side of the constraint that causes problems for the solver on the Macs if it refers to cells that have formulas. With this solver set up, we can solve, and we get the same solution that's shown in the SOP tutorial.